Fine, let's begin. So as you can see here, there's a topic measurement of length of an object using vernier caliper. So what's the procedure? If your vernier caliper is having no error, then the formula is main scale reading plus vernier scale division into least count. Okay, and then you are going to get observed length. But in case if there is an error in your vernier caliper, so for that the formula is observed length that you got minus 0 error. So minus 0 error in bracket it is written with sign. So with sign it means that if it is positive error, then we'll write plus whatever the error is, and if it is negative error in bracket you are going to write negative. Okay, let's say example, the error that we got is positive error. Okay, so positive error that is coming is, let's say, plus x. Okay, so the formula for correct reading will become observed length minus, in bracket you are going to write plus x. Why we are writing plus x? Because the error is positive. Okay, and then if you solve this, here this is not 0, this is O. Okay, so finally your formula for the correct length will become observed length minus x. Understood? Similarly, if the error is negative, okay, so for negative error we are writing minus y. In that case, the formula for your correct length will become O, that is observed length, minus, in bracket we are going to write minus y. So you see, if you open this bracket, then you are going to get O plus y, because minus of minus will become plus. So basically what I want to say you, that if it is positive error, then positive error will be subtracted from the observed length, and if the error is negative, then the negative error will be added in observed length. Clear? Hope you have understood. Now we have to begin with a new topic, that is screw gauge. So the screw gauge, the diagram you can see in the picture. Okay, now there's a YouTube link given. So if you click on this YouTube link, then we'll be directly come to this video. Okay, so let's see this video, what they are trying to explain us.
Use an ordinary scale to measure up to 1 millimeter accurately. You also know that you can use the vernier calipers to measure up to 0.1 millimeter accurately. Please
see what they are saying. With the help of ruler that we are having, we can measure up to 1 mm. If you are having a vernier caliper, then you can measure correctly up to 0.1 mm, that is 0.01 centimeter. But if you are having another scale that is called as a screw gauge, then you can measure more accurately. Let's see what they are trying to say.
Count of the vernier calipers is 0.1 millimeter. Therefore, you cannot use it to measure any dimension less than 0.1 millimeter accurately. A screw gauge is used in such cases. It is used to measure up to 0.01 millimeter with greater accuracy. Thus, it can be used to measure the thickness of thin objects like wires, glass sheets, and so on. The screw gauge works on the principle of a screw in a nut. The screw gauge consists of a U-shaped metallic frame. One end of this U-frame has a fixed flat shaft called the stud or anvil. It forms the fixed jaw of the screw gauge. The other end of the U-frame has a long hollow cylinder with fine threads inside. This serves as the nut. This cylinder is called the sleeve cylinder. On the outer surface of the sleeve cylinder, a line parallel to the axis of the cylinder is engraved. This line is called the index line or baseline. The index line is graduated in millimeters or half millimeters. This is called the pitch scale.
Okay, students, I want you to understand these readings. Okay, over the cylinder piece, you can see there's a horizontal line drawn, and over this horizontal line, it is 0, 5, 10, 15, 20, 25, 30. So actually, these readings are given to us in mm. Okay, if they are saying that from here to here, that is from 0 to 5, okay, this is 5 mm, and from 0 to 10, this is 10 mm. So 10 mm is actually equals to 1 centimeter. Okay, so this distance is around 1 centimeter. Okay, it is written here 10, but actually that is 10 mm. Similarly, this is 0 to 10, then 15, 20, 25, 30. So this all reading is given to us in mm. And this horizontal line, it is said as baseline. So over the baseline, these readings in mm is given. Fine. Let's continue further.
Scale or main scale. There is a screw with a flat tip and threads on its outer side, identical to the threads cut inside the sleeve cylinder. This is called the spindle. The spindle moves inside the sleeve cylinder.
Okay, now as you can see, the cylinder is called a sleeve cylinder. Inside the cylinder, there is a spindle-like arrangement, and this spindle actually has threads on it or windings on it, just like screw. Right? Let's see further what they are saying.
The flat tip of a spindle is nothing but a shaft which forms the movable jaw of the screw gauge. The other end of the spindle is connected to a milled head. To the milled head, one end of another hollow cylinder is connected. This hollow cylinder is called the barrel. The other end of the barrel is tapered and graduations are made. There are
Okay, so as you can see that this inside it is called as sleeve cylinder, and over the sleeve cylinder there is another outer inner cylinder, and this is called as thimble. And over this outer cylinder you can see these cylinder markings are made. Okay, and these markings 40, 45, 50, as you can see, this is called as circular scale. Okay, this is called as base scale, or we say it as a pitch scale. Okay, and this is called as circular scale. Fine. So in screw gauge, two kinds of scale are there. In vernier caliper, there was two scale, main scale and vernier scale, whereas here in screw gauge, the two scale are base scale or pitch scale and circular scale. Fine. Now the readings or the number that are written in circular scale, they are not in mm, centimeter, like this is not there. It is just a inner cylinder. The cylindrical part of that circular scale is divided into 100 divisions. Okay, that's it. There is no any mm, centimeter, nothing is written over here. This is only number of divisions. Let's move forward and see what they are trying to explain.
Either 50 or 100 equal divisions on it. This is called the head scale, circular scale, or thimble. The end of the screw is connected to a ratchet by means of a spring. When the flat tip of the screw comes in contact with the stud, the the ratchet becomes free and makes a rattling sound. Thus, the tip of the screw cannot be pushed further towards the stud. The screw gauge is also provided with a lock nut, which holds the scales at a particular position to prevent errors. Let us now measure the diameter of a metal wire.
Now they are going to explain us how we have to measure diameter of a wire. But before that, I'll tell you something about this lock nut given here. Okay, so actually when we are going to fix the object between this spindle and stud, okay, then to prevent our reading from any error, we are going to use this lock. Okay, and due to that, what will happen? The spindle and stud, they are not going to turn, and our readings will not have any kind of error. Otherwise, what will happen? If this lock is not fixed, then if you remove the object from stud and spindle, then there can be a chance that your thimble may turn. And if your thimble may turn, the circular scale will turn, then the reading will get changed. So to prevent that change in reading, we are using this lock. Okay. Now we are going to learn how we are going to measure with the help of this screw gauge. Okay. So before that, we have to learn about least count of this verniers of this screw gauge. All those things we will learn now. Let's start.
Let us now measure the diameter of a metal wire. Before making a measurement, you should first determine the pitch of the screw, the least count, and zero error of the instrument.
Okay, so we'll see these things one by one. Pitch of the screw, least count, and zero error. Let's understand what is the meaning of pitch of screw. Okay.
When the head of the screw is rotated, the tip of the screw moves either forward or backward. The distance traveled by the tip of the screw in one complete rotation of its head is called the pitch of the screw. This distance is equal to the separation between two adjacent threads on the screw and parallel to its axis.
See, by pitch what they are trying to say, if you are going to turn the scale or the thimble that you are having by one complete circle, then what will be the advancement of spindle? That is called as pitch. Okay, so I think that is more technical to understand. We are facing a little bit difficult in understanding the meaning of pitch in that sense. So to understand the meaning of pitch physically, then you can see that inside the cylinder there is a spindle, and over the spindle this kind of threads are made or windings are made. So these windings, it is actually present in all the type of screw. So these windings, the parallel distance, okay, between these two threads, this is called as pitch. Did you understand? You can ask your doubt in the chat box. But right now the meaning of pitch is the perpendicular distance between the two parallel line that is there on the spindle as a thread. So this perpendicular distance between the two threads, it is called as pitch. Okay, let's continue.
To find the pitch of the screw, rotate the head of the screw till the zero of the head scale coincides with any one of the divisions on the pitch scale. Let us say the head scale is at 5 mm. Then turn the head scale, which has 100 divisions on it, by a certain number of rotations, say 5. After 5 rotations, the zero of the head scale is at 10 mm on the pitch scale.
Okay, wait, I'll explain you what they are saying. They are saying that initially the circular scale was on 5th division. Okay, this is your initial condition, that is I. Now they are going to turn the circular scale 5 times. How many they are going to turn? They are going to turn it 5 times. And when they have turned it 5 times, then the circular scale, okay, it came to 10th division on the baseline, you can see. Okay, so when they are turning it 5 times, so your circular scale came from 5 to 10th division. Okay, so this is your final position. So your initial position was 5 mm. Okay, after making 5 rotations, it came on 10th division, that is 10 mm, right? It means what? That 5 times we turned and the difference is coming 5 mm. It means for each turn you are going to complete with the help of circular scale. Okay, you are going to get advancement of 1 mm. Okay, let's move further now.
Note the distance travelled by the screw in 5 rotations. Here, it is equal to 5 mm. Then the pitch of the screw is equal to the distance travelled by the screw on the pitch scale divided by the number of rotations made by the head scale. Therefore, the pitch of the screw is equal to 5 mm by 5, which is equal to 1 mm.
Okay, now I am going to wait here, and if you are having any doubt, then you can ask me in the chat box. See what they have said, that they are going to turn the thimble 5 times, and they observed that when the rotation is made 5 times, then there is a displacement of 5 mm. So the formula for calculating pitch is distance traveled by the screw and number of rotations made. So distance traveled is 5 mm and number of rotation is 5. So pitch of the screw is coming 1 mm. Okay, we are having a doubt now in the chat box. Why 5 times? See, I have taken 5 times. You can take 10 times also, 20 times also. So as you're going to turn other than 5 times, then here distance travel will change and number of rotation will also change. So if you are going to turn 10 times, okay, then what will happen? The distance traveled by the screw, it will come 10 mm. Okay, if you are going to turn the circular scale 10 times, then there will be displacement by 10 mm, and the formula that distance traveled by number of rotation, that will 10 mm by 10, it will come 1 mm only. So whatever number of turns you make, accordingly distance traveled by the screw will also change. Understood? Just a minute, we are having one more doubt. Okay, sir, we can change it into any times. Yes, you can change it into any times. Now how to detect how much we have to rotate? So generally for calculating pitch, we are taking it 5 times, 10 times, that much only. Okay, don't make more than that. Okay, hope that your doubt is clear. Yes, you have to start from 0 and then come again back to the 0. Okay, see, this is a circular scale, you can see. So as you are starting your journey from 0, okay, so you have to again come back to the 0, then that will be set as 1 rotation. Again come back to the 0 by turning, that will be second rotation. Like this you are going to make 5 rotations, and then you are going to observe that the distance traveled by the screw will become 5 mm. Okay, very good. Hope your doubt is clear. Let's move further now.
Using the pitch of the screw, let us calculate the least count of the screw gauge. You know that least count is the smallest measure that can be made accurately by an instrument. When the head scale is rotated such that only one division on the head scale crosses the index line, the distance travelled by the head scale along the index line is called the least count. In another way,
Okay, see what they are saying, that if we are moving the thimble and your circular scale is getting displaced by this one division, then what will be the advancement between the stud and the thimble? Okay, that value will be the least count of this screw gauge. So you can observe that it is so less, means it is more precise than your vernier caliper that you have been using. Now, how you are going to calculate the least count for this screw gauge? Okay, for that we are having a formula. Let's see that.
the least count is equal to the pitch of the screw divided by the number of head scale divisions.
Now, the formula for least count, that is pitch of the screw upon number of head scale division. Head scale division means circular scale division. So you can see here the circular scale starting with 0, 5, 10, 15, 20, 25, like that it is coming back to 90, 95, and from 95 to again coming 0, but actually it is 100. So total number of division on your head scale or circular scale is 100 divisions, and pitch of the screw is how much? It is just 1 mm. So now if you are going to put the formula and you are going to put the value, so pitch of screw is how much? It is just 1 mm, and the number of division is how many? 100. And if you solve this, then you are going to get answer 0.01 mm. Yes, we are having a doubt here in the chat box. Let's see. Sir, pitch of the screw is always 1 mm. Yes, the screw gauge that we are going to use in our lab is having a pitch of 1 mm only. But when you're going to see this kind of screw gauge is there in microscope also. Okay, so there the least count will be different. Fine. Here right now the least count that we are going to use, okay, as per that the pitch of the screw will be 1 mm only. Fine. So you can see here, see the least count how much we got. Pitch of the screw upon number of divisions, that is 1 mm by 100, that is 0.01 mm. So you can copy this in your notebook or you can take a screenshot of it. Okay, let's continue further.
As the pitch of the screw is 1 millimeter and the number of head scale divisions are 100, the least count of the screw gauge is 1 millimeter by 100, which is equal to 0.01 millimeter.
Okay, I'm waiting here. Just go through it and ask me if any doubt. You can take a screenshot of it, or if you are having any doubt related to it, you can ask me in the chat box. But this is what the formula is for calculating least count of screw gauge. Okay, and the least count of screw gauge is 0.01 mm. So this least count will be helpful when we will be going for making calculations. Okay, nobody is having any doubt. Fine, very good. Means that you all people are understanding well. Let's move further.
Before making a measurement, you must also check if the screw gauge has any zero error. Rotate the head scale such that the tip of the screw is in contact with the...
See, we have understood two things. Pitch of the screw and second one least count. The last topic we are going to study, that is zero error. Now how to calculate zero error, all that we are going to learn now. Okay, let's see.
Stud. If the zero of the head scale coincides with the index line of the pitch scale, and the head scale is exactly on the zero of the pitch scale, then the screw gauge has no zero error.
Did you understand what they are saying? No zero error means there is no error in your screw gauge if the zero of circular scale is matching with the baseline. Okay, the red color line is your baseline, that is on the inner cylinder, and this blue line is made on the thimble. This is called as circular scale. So when baseline and the zero of circular scale coincides, then we say that there is no error in our screw gauge. Clear? Let's move further now.
However, if the zero of the head scale does not coincide with the index line, then the screw gauge is said to have zero error.
Now here what they are saying, the zero of circular scale is coming below the baseline. Okay, so in this case the zero is below the baseline. There may be a situation where zero will come above the baseline. So below the baseline or above the baseline, both kind of chances can be there. And according to that, there are two kinds of zero error. So that also we will discuss.
There are two types of zero errors. They are positive zero error and negative zero error. When the tip of the screw is in contact with the stud, if the zero of the head scale is below the index line of the pitch scale, then the error is said to be positive zero error.
Okay, learn this. What is the meaning of positive zero error? If the zero of circular scale is coming below the baseline, then we say that the error is positive zero error. Okay, let's see next
If
one.
n is the coinciding division of the head scale with the index line of the pitch scale, then the positive zero error is equal to n into least count. Then the positive zero correction is minus of positive zero error. That is, the correction for positive zero error is negative. For example, if the sixth division on the head scale coincides with the index line of the pitch scale and the least count of the screw gauge is 0.01 millimeter, then the positive zero error is equal to 6 into 0.01 millimeter, which is equal to 0.06 millimeter.
Okay, now they are explaining us how to calculate zero error. So first of all, we have to check that the error is positive error or negative error. So from the diagram you can see that the zero is coming below the red line. So it's a positive error. And now you're going to check that which division of circular scale is matching with the baseline of screw gauge. So you'll see that the sixth division is matching. So number of division which is matching is 6 and the least count of screw gauge is 0.01. So your positive zero error will be 6 multiplied by 0.01. That is number of division into least count, and the positive zero error we got here is 0.06 mm. Now as yes, we are having a doubt here. Let's see. Sir, where is the negative sign? Negative sign will come when we have to make corrections. Okay, when we will be writing true length. Okay, that time we will write that. Let me write this here also so that you can understand. Okay, suppose you want to measure true size. Okay, then you are going to write that observed length minus your positive error. Did you understand? So when you have to measure true length or true size of an object, that time you are going to subtract the positive error that is coming here. Okay, any more doubts? Okay, very good. Hope your doubt is clear. So here they have written that when we have to make corrections, then we are going to write the negative sign. We are having one more doubt. Let's see that. Okay, fine. So positive zero error is actually subtracted in the observed length. Clear? Let's move further now.
Then, the positive zero correction is minus of positive zero error, which is equal to minus 0.06 millimeter. When the tip of the screw is in contact with the stud, if the zero of the head scale is above the index line of the pit scale, then the error is said to be negative zero error.
Okay, students, so you can see here the zero of circular scale is coming above the baseline. So if this is the case, then we say that the error is negative zero error. Now we will see how we have to calculate negative zero error.
N is the coinciding division of the head scale with the index line of the pit scale. Then, the negative zero error is equal to minus of number of divisions on the head scale minus n into least count.
See, negative zero error correction is little bit different. If you remember in vernier scale, then in vernier caliper actually we subtracted the number of divisions, coinciding division from 10. Here also we will check which division is matching. So it is, wait, we are having a doubt here. Sir, what if lies somewhere between 2 and something else division? No, actually it doesn't happen. Okay, the divisions are so small that if you see, then 1 or 2 division will be already matching with it. Okay, so here number of division on the head scale minus n. Okay, so here you can see that this is 95 and this is 96. So which division is matching with the baseline? This is 96 division. Anyone is in doubt here? So, but total number of division is how much? And on the head scale, that is 100. We are having a doubt here. Attendance? Yes, I'm going to take now. Don't worry. Okay. Let's see this.
Then, the negative zero correction is minus of negative zero error. That is, the correction for negative zero error is positive. For example, if the 96th division of the head scale coincides with the index line of the pit scale, the total number of divisions on the head scale is 100, and the least count of the screw gauge is 0.01 millimeter. Then, the negative zero error is equal to minus of 100 minus 96 into 0.01 millimeter, which is equal to minus 0.04 millimeter. Then, the negative zero correction is equal to minus of minus 0.04 millimeter, which is equal to 0.04 millimeter. Now let us measure the diameter of a wire with a screw gauge.